The 21st century challenges faced by the Alliance have changed significantly since its inauguration in 1949. The threats are no longer specifically territorial or military, but have evolved to include areas of energy supply, resource and communication security, harbour protection and defence against terrorism. Over the last 10 years, we've seen the increase of globalisation in the world we live in. One event in a single nation can have repercussions across the world in the time it takes the news to arrive. The globalisation of resources has placed greater pressure on maintaining the flow of raw materials, energy supplies and foodstuffs around the globe. At any one time, more than 70% of the world's oil and gas supplies are transported by sea, and 60% of the food we eat is in transit. Maintaining sea lines of communication remains as important today as ever. The socio-economic impact of any disruption in the free flow of trade could be catastrophic. The navies of the world continue to have a vital role to play in implementing foreign policy, protecting sovereign territory, and the safe passage of commercial shipping. The threats faced by all navies are numerous and diverse, including but not limited to conventional state-sponsored acts, opportunist actions from highly equipped rogue paramilitary units, and asymmetric threats from terrorist organisations and highly organised modern-day pirates. Consequently, modern navies must be more capable and flexible than their predecessors, achieving all of this in the full glare of the media spotlight. How do operational commanders provide assurance that their units are mission capable?
HMS Cumberland is in Suda Bay at the start of what will be a 6 to 7 month deployment east of Suez on national tasking. This is our last opportunity prior to entry into theatre to have a final check of our systems and sensors to ensure we're in the best possible shape to conduct operations. Also, it's a chance to see sensor performance and weapon system performance in the same environment that we'll be operating over the next 6 months.
The ability to detect threats relies on the efficiency and accuracy of the platform sensors and that they are optimally tuned to support their mission. Where can you assess capability against realistic and representative threats across all warfare disciplines? In the asymmetric threat environment, the stovepipe approach to capability is no longer valid. Data fusion from all sensors is essential in order to provide situational awareness and mission effectiveness. Testing systems in isolation does not deliver overall combat system assurance. It follows that we need to test systems simultaneously in a representative environment against realistic threats. NATO FORACS ranges have the capability to assist all NATO nations to test the various sensors of all of their maritime assets in realistic conditions. More than 30 years ago, it was decided that NATO would build maritime test ranges to conduct accuracy, alignment, dynamic performance trials on naval weapon engineering equipment. FORACS ranges are instrumented test ranges which offer high fidelity accuracy to allow measurement of errors in sensor performance. The ranges provide the facilities to test the full combat system in dynamic conditions, covering radar, sonar, ESM, infrared, TV, laser and optical sensors, navigation, gyro and communication systems. NATO FORACS is a one-stop shop offering an unrivaled capability to support the needs of a modern navy. The ranges were built with NATO infrastructure funding, and the NATO FORACS project was born. The FORACS ranges are located at Suda Bay in Crete, Stavanger in Norway, and with the North American range co-located with the Atlantic Undersea Test and Evaluation Centre, AUTEC. More recently, FORACS has developed a deployed test capability which has been successfully deployed to multiple sites in the Atlantic, Pacific and across Europe. The NATO FORACS project, with the experience gained over many years of testing platform sensors on all classes of ships, submarines and maritime aircraft, developed a 3-day operational test series. This new test is unique and offers effective test scenarios specifically tailored to the ship's operational tasking and expected mission and the threats that the ship may encounter in theatre. It is aptly named the Operational Capability Confidence Check, or OC3 for short. The aim of the OC3 is to give the command the confidence that the ship's systems are performing at the standard required to support their tactics and to undertake tasking commensurate with the threat in their specific operational theatre. The serials conducted are determined by considering the time available for testing, ship's priorities as determined by defects, performance concerns, tasking to be undertaken and potential threats. For every threat, there is a specific capability chain that details the timeline from initial detection to target prosecution, combining operator actions and equipment settings and responses. Personnel and equipment must work in unison for a successful outcome. Any chain is only as strong as its weakest link. Operators and engineers must be able to answer questions such as: can my ESM detect a specific emitter and pass the correct information to decoys? Does my surveillance radar detect and track a sea-skimming missile at sufficient range? And do my fire control radars detect and acquire the target at adequate range to allow coordinated hard and soft kill? Data can be captured either manually or automatically by interfacing the ship's combat system highway with the ranger's test system. The OC3 is conducted over 3 days on a NATO FORACS range and is a combined engineering and warfare serial. The first day is spent dockside instrumenting the ship, establishing the ship's centerline, conducting static testing. Whilst dockside, the key ship's personnel are briefed. The static performance of sonar, radar, gyro and navigational aids will be conducted, confirming the range, bearing and positional accuracy of the systems. This data serves as a baseline for comparison with the dynamic data captured during the sea phase, as well as providing an early indication of any underlying performance issues. The ship will then spend 1 to 2 days at sea on the range to conduct dynamic performance trials. The range has the capability to test across the full spectrum of all in-service ESM systems: navigation radars, surveillance radars, fire control radars, electro-optic sensors, TV and IR sensors, laser rangefinders, sonars, and to plot antenna radiation patterns. The highly accurate FORACS differential GPS system can be used to record data on tactical turns, allowing the impact of changes to the platform to be assessed. These factors can potentially have a significant effect on weapon and sensor performance, influencing the way they are employed. Reliable communications are essential in order to maintain situational awareness and exercise command and control. Measuring the antenna radiation pattern for the multitude of antennas fitted to modern ships allows polar plots of performance and hence blind arcs and areas of degraded coverage to be determined. By conducting the checks on the ship, seaboats and helicopter, a full picture of the limitations of each asset will be known. This information is crucial when coordinating boarding operations to ensure that each asset is positioned to ensure that constant communication and situational awareness are maintained. In addition to the capabilities offered by the range, the OC3 can be supported by fast patrol boats and specialist aircraft with low-level target towing and advanced electronic warfare capabilities to simulate the missile threat. The use of additional assets allows a thorough and realistic test of the ship's capabilities against representative targets. All of the targets used are differential GPS data logged in order to provide ground truth data. The ability to reconstruct events and determine how the operators and combat system responded to the threat is a powerful tool in establishing overall performance and effectiveness of weapon systems, defensive posture, and standard operation procedures. Once the individual elements that support a capability are proven, an end-to-end test of each capability chain is conducted to ensure that the ship can counter a particular threat from initial detection to final engagement. The serial is conducted with operators following their standard operating procedures, as they would for a live threat. This serves to demonstrate that in the most demanding of dynamic scenarios, that the entire combat system is capable of defeating the threat. The data collected throughout the serials allows for accurate analysis and precise reconstruction of events, allowing system engineers and operators to determine exactly what their systems did or didn't do, removing any ambiguity. The OC3 is a combined warfare and engineering evolution. The trial is driven by the warfare team in the ops room, allowing the weapon engineering team, assisted by trial staff, to focus on assessing system performance. The range can not only test the ship's systems, but can also be used to test seaboats and helicopters, allowing the overall capability of the platform plus all of its organic assets to be determined. On completion of the OC3, a wash-up will be conducted with the ship and preliminary results discussed. Quick look signal will be sent, detailing the status of the platform and any particular areas in need of support. All of the data captured will then be post-processed and collated into a detailed report for distribution to the ship and key national stakeholders.
As a result of the system checks conducted, we've further increased command confidence in the operational capability of HMS Cumberland. This is the last in a long series of checks post-upkeep period, including high seas firings and directed continuation training, giving us the maximum amount of command confidence in our equipment prior to going into the operational theatre.
Recently completed OC3 events have identified areas of performance where mission capability could have been compromised had it not been detected by the FORACS range, with its unique combination of realistic target presentation and real-time data analysis. FORACS' commitment to invest in new and relevant technologies to meet the evolving testing needs of participating nations will ensure that FORACS is ready to support alliance nations as they take on the challenges of ever-changing threats.